Anyway, 1000 minimum cost to merge stones. There are n powers of stones arranged in a row. The I powers of stones, I of stones, stones sub I stones. A move consists of merging exactly k consecutive powers into one pile, and the cost of this move is equal to the total number of stones in these k piles. Find the minimum cost to merge all powers of stone into one pile. If it is impossible, return -1. First of all, what's n? Okay, so n is 30. Oh, k is 30. What's k again? Oh, k consecutive files. Okay, so you have all these operations and they cost, and each stones could be up to 100. Okay. Hmm. So my intuition is that it's one of those n cube dynamic programming, but uh, how do I do it effectively? How do I represent that? Hmm. So the Tama, okay, yeah. So dynamic programming is always my kryptonite on these things. So I'm just thinking it through a little bit how I would kind of do it. Um, if k is equal to 2, then it should be straightforward in that, well, in that I think it is it's very close to uh, what's it called? One of those parametric dynamic programming problem, which is I'm hand waving a little bit, sorry, but if you look up what's it called, matrix multiplication, and then you have to kind of do different ways of doing parametrics. I think that's kind of similar, but okay. So let me see. So my first intuition is, and for this I actually like using a C-like language because I don't know, I just trust to operate. It just runs a little bit faster for me, maybe. Maybe I gotta get used to it though. I do the memo a little differently. Um, but okay, so let's say if we start with left right, which is the total cost us to do left and right, or left to right. But the k, how do we keep track of k? I guess just x merges or something like that. Oh, you need, huh? Oh, that's a little. I might miss this actually. Exactly k consecutive. Okay, so that's why this is -1. Uh, hmm. So you, how do I think about it? I mean, well, n is 30, so you can maybe take advantage of that. It's either that or maybe take advantage of the fact that stone sub I is equal, smaller than 100. Uh, because I have some like vague idea about it, um, but it's like n to the fifth or something. But what is 30 to the fifth? Just calculating. Okay, actually, even 30 to the fifth is 24 million, so it's not that bad. But basically, my idea is that you think of this as the sum of kind of like partition, right? Um, so you break into 3 parts, and then each of those 3 parts, you just merge them together in some way. Um, and because we have n square spaces because it's left, right, but each of them takes possibly n to the third. This is n to the fifth power, right? Okay, but since n is only 30, but I think we could do it. I'm going to try it, and then if not, we'll see. I hope I didn't really explain it that well. but let me try a little bit to explain a little bit before I start going. But basically, you have basically like a pile. I guess I could just even copy paste a pile, but let's say longer. So let's say copy and paste this twice. So basically, the best answer here is just you go to some subset of, I don't know, I'm just picking like random things, right? Like the best answer for this, the best answer for something like that, and then the best answer for the remainder, something like that. So, and this is NQ because you just have like an IJK for loops to kind of go through it. Actually, maybe with IJ, so maybe this is N square because there's only 2 partitions, so you could kind of actually maybe enter 4th, then it may be way faster. But then you take these and then you kind of sum it up in that way, and then so these are your kind of pieces, and then you merge those 3 together. So that's your subproblem. I'm a little hand wavy on the diagram program, but hopefully let me do this in code, and then hopefully that'll be clear in code. I don't even think I believe myself in that. For dynamic programming, I feel like sometimes you see the code, you're like, oh yeah, that code looks fine, but you know, but looking at the code doesn't tell you anything about the dynamic programming. So I mean, it doesn't, not nothing, but you're just like, you know, cool. How do I describe this? Sorry, let me finish. What's the max number? 100. So yeah, let's just say a billion. What might be that? Maybe that's too high. That's 200 billion. Okay. Basically, so fundamental part of dynamic programming is kind of breaking kind of one big problem into subproblems. And I think the way I think about it is giving, say, this array, looking at line 19, we're trying to, so because, and oh, this is, actually, no, like, sorry, give me a second. For some reason, I got stuck on the k equals 3, but that's not true. I mean, like k for this case is true, but k could be more than 3. Then you can't have a for loop. Yeah, you're right. Sorry. Oh man, I'm having some reading comprehension problems today. Yeah, you're right. Sorry. Yeah. I take this back. So I'm glad I didn't. Thanks for stopping me just in time, man. You're my savior today. Uh, huh. I forgot. For some reason, I just read this equals 3 generically. That's kind of tricky then. So you want. Huh. That's why I got. Okay. Well. Is this right? Maybe 30 is a hint. How do we brute force this if we want to? Two to 15. Sorry, now I'm just thinking more. Thanks for catching. I would have typed like for, I don't know, possibly a way longer and then get confused and then be like, oh no, k is actually not a constant. Also, I'm not even sure this formulation is correct, to be honest, in that Actually, maybe it's okay with this k is constant. But you definitely cannot. Can you do it this way with double program? I mean, maybe we just have to figure out k. Something like that. What's k again? Okay, it goes up to 30. How would you do that? Well, then you take the first chunk. For at least k. Maybe this is okay. I'm trying to think about how to analyze this complexity wise. 15. Well, this is just 3 times 3, which is 5. I'm just using the calculator. Okay. I'm also thinking of another. I'm also just thinking about how to do things in parallel. Sorry, how to do a brute force if I have to. But yeah, how would I do a brute force? Well, I mean, you just do a recursion type thing, but man, people keep on messaging me, sorry. Turn off, do not disturb. Does this make sense? Yeah, I'm gonna try it. I don't really have any alternative for now, so oh man, this K is confusing. How easygoing. I am not familiar with Code Wars, though some people have brought it up a few times. I should look into it actually. I've just been lazy, if you will. But do tell me more while I try to figure this out, if you want. To be honest, I'm really not confident about this, but I want to see where. Maybe this will give me an insight, even if it's wrong. I think I'm a little kind of feeling out this problem a little bit. Because I didn't really consider. We're not greedy, right? But that would be interesting if it was greedy. No, I mean, yeah, I mean, I'm just practicing for kind of fun. I mean, I'm not training for an interview, like particular interview, but you never know. And I guess these things are always fun. And I actually just enjoy these in general. So, you know, but it is kind of interesting. It is definitely challenging in a way that, I mean, it doesn't come up at work as much. And it's not this level of stuff. This one is very challenging. But I'm also confident enough to say that probably this would not show up on the interview. I mean, if it does, then you just grab your stuff and get ready for your next interview, because I don't know, that one isn't going so well. But I don't think anyone reasonable should ask this anyway. I was just talking about difficulty inflation too, where the more recent ones are harder. So yeah. Okay. My base case. What happens when the case is 0? Yeah, I don't think this is right, because I have to also carry the states of or the sum of the other ones in a weird way. I don't know. What's 30 choose 15 again? Did I do that? 30 choose 15. Let me do it in Google. That's like the worst case. 30 choose 15 is only 155 million. Maybe that's not so bad. So 13 choose 15. So sorry, I kind of abstracted away for a little bit. But 30 why I said 30 choose 15 is because you think about it in partitions, kind of what if k is equal to 3, then you can think about it as n choose 2 gaps, or n plus 1 choose 2, or something like n plus k choose k, or something like that. So the worst case in theory for 30 elements is n over 2, so it's going to be like n choose n over 2, something like that. So it's like 31 choose 15, which, I just Googled this. I forgot what it was, but it's like 100 and something million, so maybe that's right. 31 choose 15 is 300 million. Is that fast enough? So, like, can we do the brute force E thing? Eh. It's going to be K, but then you have like this ridiculous complexity that I don't know about. I don't know. Okay, I think this is. I mean, okay. Let me think a little bit. I think this is probably the way to go, but I don't know how to do the subproblems one. What are the subproblems? I have trouble adding the K part in. What does K mean? Not K moves, but K as part of the merge. What does that mean? How do we put this into? At least I set up the dynamic programming pretty. Also, this is just wrong. But what is doing? What is the best given this k? We're gonna merge this. That's fine. Still think about too much about the partition. Say k is equal to 1. Well, k is equal to 1, then it's just the sum of... No, it's not even, right? Well, k can't be 1, right? I guess it could be 1, but then that's just... Oh, it's going to be negative 1. Unless it only has one pile. Yeah. I guess that could be a base case. Is it? Actually, maybe no, that doesn't make sense. It's just 0. And then if else, then can we combine anything? Oh, I guess I should actually return infinity. Okay. A base case. How do you build on top of that? I guess we need to. I need to do a partial something. Yeah, actually, I don't know why I had so much trouble. I guess it's similar. If we have k, then we just do a subset of some sort of split. Well, yeah, I think Leetcode is also. I mean, it's Sunday after or evening. Maybe that's just a busy time, but. Yeah, I guess actually. Infinity, because it was k is more than 2. Okay, and then. Not true. K is equal to 1. What does k equal to 1 mean? Wasting too much time on base case. All right, get back to the base case in a bit. Let me. Usually I think about it the other way, but I'm just trying to do a little weird. Well, I'll just do the traditional divide in the middle thing. No, that's okay. And what is it going to calculate? To I, something like that, right? Well, kind of. Some other functions. Oh, well, there's a k, for example. That kind of makes sense. Yeah. What does this mean physically? I mean, that's like the traditional quote unquote, one of the traditional DPs. Does this mean anything here? I mean, that's what I'm leaning toward. It's either that or some really clever brute force if n is 30. Maybe I'm doing this k wrong. K should not. I think I confused k a little bit. I think what this should be maybe is. Let's just go this x then. X piles left. Maybe that's a different thing. But we want one pile left in this case. So we want the left side to be on one pile, and then the right side to be all these other piles. Does that make sense? Yeah, okay. And if f is equal to 1, we want the best ends to come out with one pile, then if, oh man, I overloaded it a little bit. Minus left is equal to k. Yeah, the k threw me off quite a bit, to be honest. But let's need to think about this a little bit. Yeah, I'm a little hacky. Why is it in a different color? Yeah, I guess I should pre-calculate this, but I'll optimize this later. For now, I want to already prove this as a proof of concept. So you could pre-process this with what's it called? Rolling sums or something like that. So is this off by 1? Do I still not have a thing on the thing? Yeah, this is now getting into dubious code situation, but no, then it should be -1. Yeah. I just don't want to. Yeah, I guess I could pass that as the recursion. It's just a pointer, but. No. Very optimistic answer, but. Oh, maybe this has to have a. Does this have a cost function? Yeah, I guess so. But we have to merge these two files. Why does this work for? Well, they're not two piles. They're just. Given k, these are just the ways to kind of break it down, or like the subproblems of those. Sorry if I'm just mumbling to myself. I'm still trying to figure out myself. I have to pre-calculate. This is just something I use it a lot. I don't need that. I know. The sum is just. Maybe this. Could be off by one, actually, but we'll play around with it. Oh, I forgot to put this back here. Everything should be within, so why are you getting... Oh, if I just... Well, we don't cache anything, so... So never fix this. Yeah, well, I guess we just don't have enough base case for that. How did this work before? Policy goes to 1, then you put it all together, that's fine. There's another base case. Otherwise, return infinity. Okay. Oh, that's only gonna happen now. Quite only. Oh, does this crash before? So. persistence. I thought it was working okay before, kind of. Okay, that's how that it is. Oh, huh. I forgot that we want the answer for 1 power left. So this goes to 0. That's why it's going to infinity, because it's going. But and I wanted to count up. This to t minus 1. Because you start with, yeah, I mean, this recurrence seems okay, though there's maybe an off by on somewhere. Hi, not shift. That's what I'm trying to figure out a little bit. I also am running into some issues that does this actually tell you anything? I need to use start from scratch or something. Sorry, that was just crashing from here. Oh man. Oh, because this is max, not what a silly mistake. Well, I can't believe I spent that much time debugging that, but okay. This kind of is what possibly. You want I to be 1 power plus this to be the other 2 in this case. How is this not going to infinite loop? I guess I need an extra thing where something like if left is equal to right. What does this mean? This returns 0, right? Unless power is but oh, this is like 1, which I guess this is actually already taken. No, maybe not. I don't know. Return infinity. So you needed multiple powers. And then this is just merging these, so you need a cost, which is again, this might be off by 1, so double check. Yeah, okay, well, let's just print something real quick. Let's go to 3 is 7. That's clearly not right. I'm off by 1. I think this. Yeah. Yeah, that's fine. I know there's gonna be some weird off by one issues. Okay. Yep. Right. That's the way I traditionally do this. Is this? Now. So all this sum is doing plus one because that doesn't make sense, but I'm done between this one. No, this is plus one, I think. Okay. Yeah. So it's not gonna be the right answer, but that's fine-ish. Oh man, I messed up my base case. Maybe. Let's try to save it. But so we want the answer to be one pile. There's like some weird thing. You have one pile and you have this there. No, I'm inclined to say this is right, but why does that go into infinite loop? What am I doing? Yeah, at least looks like it should be fast enough. If it didn't crash. Things are fast as long as you don't want the right answer. But Leetcode's doing this slowly. Okay. Another base case, I think. This doesn't make sense. Mm-hmm. So the 1, 3, 1. It passes all this. It should be a negative one. This should be infinity as well, but because there's 3 pile, but then you try like okay, well there's been 1 pile and 1 other pile. That's itself. Missing a base case is probably why. You want one pile from 3 piles. 2. Should be actually doable. I think I just have a weird thing. I just want 3 1 recurse itself. Oh, because this loops to 3. And then this is 3 3, which is fine. There's a special different logic for one pile. Maybe. Well, if it's one pile, it's either this or you want there to be k piles. Right? Maybe that'll get us out the loop. Well, let's hope for. Okay, just same crap, different day, kind of. 1 3 2. What is that? 1 3 2. 1 3 2 goes to 1 3 1 probably. Okay, well, let's do this. At least I don't have to complain about the examples not being exhaustive. But, well, I mean, actually, I take that back. That's not true, but. Probably still missing a base case, but. That looks okay. Why does that? Okay. Sorry, friends. DP is hard. So you have 1 3 and then 2 piles left. It goes here, it goes 1 3 1 and then 1 and then. This is off by 1. Oh my god. if that's the only reason why I had it for so long, but I just kind of, did I even need this? Maybe I did need this actually. Let's see. I didn't even need that, at least for this form. Now I feel comfortable, so I kind of want it. Yeah, happy about that. Maybe I'll play around to see if that works later, but let's have enough. There's no even good rationale about it. It's just I didn't really think about it after I wrote the code, because I just sometimes it takes certain things for granted in a bad way. Oh, okay. So that's good that I at least have one more other bug. But let's look at the subproblems. A lot of things are not possible, which is good. Can't believe I had that off by one. So what happened was that this was basically calling the same calling itself, because, and it didn't even make sense, because this is this gets dropped off. So yeah. Also, maybe I could do another quick base case, which is if house left is bigger than right minus left 3 powers left minus 1 or plus 1. So that's a 3, so yeah, plus 1. No, minus 1. It's 3 power 7, you go from 0 to 3. You want that to, no, that's a good case. It goes from 0 to 2. Okay, plus 1 here. We can return, because that's an optimization. So okay, this is still what? Oh, I guess I should take out the other 2. This is gonna just give me some bad printing. Oh, I guess everything's just impossible, but I guess I never tried K over 3. I'm just double checking all my code. But so 0 to 2, it should be at least give me an answer. But we may not, just not call it. Okay. Let's just see if it even goes here with 0 to 2. Okay, so it does have 0 to 2, 1 power left. That's 1 to 3, 1 power left. Also good. Okay, that's kind of the stuff we expect. Should be a 2 to 4, maybe. 2 to 4, 2 power, but not 2 to 4, 1 power. I have another off by 1 somewhere then. Quite off by one way. Getting this wrong. I have to double check this because I might actually overflow if I'm not careful. That'd be funny, but it should be okay. This should be at most 2 billion plus something that's hopefully less than 100 million. If we want to do 131, we should at least have. What is the recursion for getting the middle? I guess that's what we do here. By having 1 to 4. No, but that's. Maybe my formulation is weird of the base case. This, 3. So what I'm thinking right now, just to articulate a little bit of the thought, is that we should be able to do this as a first move, but it's not considering it. So that means in our dynamic programming, I mean, it's not related to the answer per se, but it means that something's not getting considered. Because in theory, that is one of the possibilities, and you want all possibilities to kind of occur. This is something by the base case. Does it matter if I have to calculate both of these? Just for giggles, let's see if I could do something like that. Do I need to? I just assumed I didn't, but maybe it's something weird. Okay. But does it give me the 2 to 4? Yeah, okay, so at least it does that, which is what we were looking for before. Okay. So we have this 2, 4 in one pile. That means 1, 2, 3 and 2 piles, or 0 to 1 with 2 piles. Maybe that's why I didn't know. Because you want 2 numbers with 2 piles, and I don't have that as an edge case. Well, I don't have that as a base case. I think it's related to this. So we can actually clean that up even. It's equal to right minus left plus 1. Then like that maybe. I don't know if I deleted an infinite case, but I think that's just a base case in general. Okay, I mean, it's progress. This is not return infinity anymore, so it's possible that I'm just missing something dumb, but let's see if I need that. Because maybe that's what I was missing a base case. Yep, it's the, okay, so now that's clearer. Okay, So now just let's see what in the so this is our table roughly. What is it missing? Why is it 26? So that was like this is. Assumed 2. I guess let's just print this out. So we also have to print. No, maybe that's okay. Right, what's the basic case? Was very hopeful that that's the case, but okay. So cell 4 goes to, how do you find it? So 3 and then 4, which is double check that I got the right problem, because that has happened before. Where I just put in something totally incorrect. Yeah, let's test some base cases. That's right. At least knows how to add it correctly, which is always nice. So we want this. That makes sense. And then 386 is just literally the entire thing. Just 8 times 306 is 17. Oh, no, no. This is right. I have the cost function in a weird, but I feel like I'm close with this. It's painful. Is this right? No, this is not right. Why is 132 with 2 powers 8 to have a base case? That's wrong. Is this off by 1 somewhere? Or maybe it just happens to be also. No. 1 to 3, 2 powers. This should not be 8. Where is this finding this? One pass left. Okay. No, this can't be pointing from here because power snap is not 1. So, but how else are you going to get 2 powers from 1 to 1 to 3? That doesn't make sense. So I definitely have something wrong here because Because the good thing about having these subproblems and printing them out is that each of the, like, you could, these mean something definitive, right? And the reason why I point this one out is that it means that from index 1 to 3, for k is equal to 3 with 2 piles left, that doesn't make any sense. What do I do for piles left equals 2? I guess I don't even use this anymore. To do something, maybe that's a base case. Because this is, maybe this is where I do piles left. I think I kind of messed around a little bit too much. At least this is more correct. Still not see why it's 6 though. There's no piles, then is it 0 or infinity? Yeah, probably infinity. I'm just doing something wrong. Maybe. Yeah, I'm making progress. It's just a little tricky. At least it doesn't screw me. But, okay. So 4 and 3 piles. We just literally the problem, we get 26. So 2 with 1 pile, we get 9, which is correct. Multiple times. Yeah, I don't know how you would brute force this part. I mean, yeah, I mean, you could do it, but it's probably similar to how I'm essentially doing it, but without the memorization, to be honest. So that's probably why I was, yep. 1 to 4 with 2 piles. Does that make sense? Is 22 the answer? So it's 22. Let's see. That's the subproblem. No, is it possible? Oh yeah, I guess that's true. But then that means that this should not be the end. And that means this is not true, is it? Oh no, it's 2 piles, not 3 piles, that's why. Let's play around. I mean, that's a different problem a little bit. But it thinks that I could do in 22, which is the issue. Why does it think I could do in 22? Do I have a function that's wrong somewhere? Because apparently the best you can do in that subproblem should be 25. And it thinks you could do in 22. Oh no, that's for 2 piles, but k equals 3, so that's not true, right? I retract that. Man, and this is right after a week where I was like, oh man, I'm starting to get the hang of this dynamic programming thing. 22, k equals 3, so, well, I mean, there are only 2 possibilities, which is combination of this, which is 1, 2, 3, 9, 14, 4, 6, also 14. Is that right? How did I get 22 then? Oh my gosh. This is dumb. I'm dumb. That's not the cost, is it? Because then that's just a constant. What is the cost of merging things? We'll see what happens. I feel like I'm very close, but I'm missing something a little bit along the way. Let's just wait a little bit. That should be 22 though. There should be like 17 or whatever I said it was earlier, 14. Yeah, it should be 14 and we just combine one thing to put two columns. I don't know why this is it's been lazy. I just need to print out more stuff. This also makes sense. This should be okay. So that's how you combine them. Why are you 25? Also, put an inline. I'm not gonna lie, if it was 26, I would definitely have submitted and YOLO it, but I just don't see where the 26 is coming from. So for the best 26 is from the split where the split is from 2, so 0 to 2 with one pile, which is 9, and then 2, 4 with 2 piles, which is also 9. What? Oh no, it should be 1 for 1 pile. Something's a little off. I'm doing this a little weird. This shouldn't be chaos because this is so this formula is if I want to get 1 pile, but I don't want to get 1 pile. I want to get piles left. Yeah, now this is more I want, I think. But so still 2 with 1 pile, and then 3, 4 with 2 piles. That's 8, 9 plus. That's 9 plus 9 plus 17, so that's 26. I guess mathematically that's right. But it's not doing the do I calculate when I is what I want is I want this to be 1 pile, maybe. Do we calculate that? 0 to 3 in one pile. Well, at least you know that I didn't pre-calculate the answers. Yeah, these are infinities. So guys, so we want to know if so 3 with 3 bars. This is infinity, that's interesting. Because we want this to be 1 par. Which calculate 0 to 3 with 3 piles. 0 to 3 with 3 piles is, I guess, infinite. Because you can't do it. There's an off by one somewhere, and I'm stressing out a little bit. I mean, that's fair that this cannot be made into 1 pile. Could be done into 2 piles, which do I need to do this thing? Still no go. So 3 with 2 piles, 19. What am I doing wrong? So this with 2 piles at 19, which I think is right. That doesn't make sense. Did I have this sealed with 219 before? Not sure if I need this. So that means that it's not merging something, right? But I guess I didn't have that before. In that case, why is that giving me 26 if because if this is the case, then you merge that with 4, 4, and 1. Which is I guess if this is 19, then you have to merge all that. Am I doing this way? So 3, 2 is 19. No, that's not right. That should be... You don't sum up the piles in it, so... So 0, 3, 2 should be 6, 7, 8. This should actually be 8. Right now, no, it should be 8. Well, yeah, something like that. I'm just phrasing this problem really weird. Let me see if I could start a little bit fresh. This kind of got a little out of hand, but so pause. Pause. Put this up. It's true. There are more piles than we have in the thing. We know that's true. If it's go to the right, then pass that, if it's go to 1, you return 0. Otherwise, you return infinity, right? Yeah, return infinity. What's next? I guess the pass you go to 1. This is already done. So this is just one merge, then we just calculate the sum from left to right. This is the math in this is right? That'd be funny if I just found out that I'm off by 1 all this time. It's really dumb. 2 to 4. Let's just print out this particular thing. Just want to double check my math. 2 to 4, so yeah, okay, that should be right. Okay, at least by spot checking. If not, then we do recursion, right? Left, right, and k, because that's you want that there to be k piles to do the left, right. That part is right. Oh, this is wrong. This does not include the cost. Sure, so I use this a lot, it seems like, so maybe that's why. Because I just kind of, I didn't actually merge them together. But that maybe that I put in the cost somewhere low, like this one. Maybe that's not necessary. I don't know. Yeah, if I'm doing it at the one place, then maybe I don't need this. Well, let's play around. I'm not gonna lie. I'm just kind of seeing what sticks a little bit. Okay. Base cases are hard. Let's at least test the other ones, because I'm not super confident. Okay, at least it's right. Wait, I have to put somewhere. Let's test a little bit more. well, that's good that, yeah, because okay. I don't remember to do this, but I forgot. Well, I think I was thinking about it in the beginning. But, that's one, then you already have one pile. Okay. Return -1. This code is a mess. I'll criticize it later. Don't worry. Well, looks like my code is better than their code slightly, at least in this edge cases. But I didn't look to see if they're routed each. Oh, K could S to be at least 2, so I guess we don't have to check that one actually. Actually missed that. That's my fault. I lied. Okay, YOLO. Yeah. Time to exceed it, then not remember cache somewhere. Okay, I mean, this is just n to the 4th, probably. So, okay, let's see. That's very helpful, but I mean, this seems to, I mean, it's a little slow, but it seems to have worked. Maybe I didn't cache something quite right. It's only halfway through, so maybe it's just a summation of these things. And I could also do things slightly faster. I guess I could cache this actually, because that is possibly an expensive calculation. Okay. That we never cache, so we never. Maybe this one next if we need to, but wow, it's even slower. Is that right? Is this consistent? That doesn't make, shouldn't make sense. So it's fast enough for this test case, but I think it's what you call it? But yeah, the summation of the time is too slow. I don't know. Let me just. Well, I think some of it's also I use infinity, so maybe I need to be a little bit better because I use infinity both as marking as unseen and also as anonymous, so it probably recalculates the infinite stuff a lot. What the heck is going on? So I think that's what I need to do. I'm so surprised that this got a little lazy. I just also confused myself at some point because it's probably slightly hard. That's okay. So it's best as infinity, that's fine. Yeah, okay. I'll explain in a second. Let me just submit it to see if it's faster. I believe I made silly mistakes even after oops. Okay, cool. Not that fast, but don't use that much memory. I'll walk through my dot process a little bit, and I think there's I don't know. not saying that's the right thing to do. I'm just what am I summarizing the last 80 minutes or so, which thankfully is not common for me to take this long. But I also, but yeah. So I think for dynamic programming, there are a couple of kind of common ones. There's polynomial time ones, which means n squared, sometimes n log n with some binary search type thing, and another one is n cube, and n squared comes up in dynamic programming when you only need the suffix of a stream, right? So you could almost like it's almost like an online E algorithm where it's like for the first x or first n or whatever, and so that and then when you build on that, sometimes it's O of n, sometimes n squared, and so forth. You have to do some kind of what do you call it? Like subsequence type things. Then it's going to be n squared at least, and that's why I did here with left right, which is kind of intuitively how I thought about it. Is that once you merge what's inside, then it effectively you look at bigger subproblems that way. Don't know if I described that right at all, to be honest. And I think for me, I just kind of not brute force, but I just kind of have an intuition about it being one of the subsequent ones. So I kind of, and you kind of, if you go back to videos, see me do stuff from left to right. I didn't have to power stuff at the time. I was, but I think at some point I just slowly I think reformulate the problem in terms of like the number of powers you want, which is what the power left is for. And in this problem, I want power stuff, which is fine. Which there are a couple of subproblems you could divide it into, which means left to right with some. So how do you get x powers, right? Well, you get x powers by having some portion of the interior as one power, and then another half in another x minus one power, right? So you have these two, and then you add it together. So that's just like way of kind of doing the partitions. I think actually I very clumsily alluded to this early on with kind of I guess I deleted my comments, but where it's just another way of phrasing, like given like a lot of these whatevers, how do you partition them in some way, right? And this is kind of how you generate. I was thinking something more brute forcey, but this kind of recurrence is generally how you kind of do that, because at the end though, and the cost function is a little tricky to calculate depending on how you do it, but I'm not explaining this well at all, I don't think, but I'm unfortunate. But this is a common pattern that comes up in partition dynamic programming problems. And when it comes to cost, it's just the cost of kind of merging them together, which in this case, you actually don't merge them on the sub. You merge them when you have all the pieces together, which is how I got confused a little bit. And then you start out with only, because you want one pile, but to get a one pile given k, you want to merge k piles, right? So this is where this cost comes from. And this cost is just the summation of all the stones inside from left to right. The kind of observation which I took for granted a little bit, which I can explain, is that let's say you have, I don't know, 5, 10, 15, 20 or something like that. And let's say k is 2, and no matter which, we could even actually just do 3, right? Let's just pick 12 so it's more obvious. So you could either merge the 5 and the 10 first, and you get 2 piles, and then it goes to 27, right? Or you could go the other way where, but you notice that here, the 15 denoting that we merged these two, this is literally just the sum of these two, right? So you can actually phrase this as 5, 10, and so forth. Um, and so the calculated cost of these two merging is just literally the sum of the initial way from left to right, and that's the cost of it. And I did some optimizations here to kind of do the preset sum and so forth. But uh, but yeah, I don't really have a and I did a little bit of a postmortem. I did make a mistake in that I was pre-using the infinity as denoting whether we calculate that or not, and that's why we got the time limit exceeded, because for impossible routes it keeps on recalculating, so it was not properly memorizing. I think if I were to do it again, I would just probably have another view, or if you do it in another language like Python, then you could see that you didn't cache it. So it's more obvious because it's not necessary. It's not just binary and so forth. You needed one more state. Um, but yeah, in terms of individual problem, I wouldn't worry that much about it in the sense that I don't know. I think this is probably a little bit too hard. I think there are a lot of ways to do something similar to test people's skill of dynamic programming that are a little bit more standardy and a little bit more straightforward anyway. That's what you're testing for. So I think, well, this is an interesting problem. I don't think this is a necessary interview problem, though I guess as things get harder, so maybe I'm wrong on that one. But I think this is definitely a little bit too hard on a programming interview. But let me know if you don't agree, because maybe things just get harder and harder over time. Oh yeah, complexity. This is n to the fourth, I think, or n to the third times k or something like that, because this goes k times, I think. But yeah, n cubed times k. Maybe we could do a little bit better with space if you're really slick about it. But yeah, I'm a little tired from this forum, so definitely if y'all have questions, please let me know. Yeah, I don't think it'll be a great interview question. I think, but in terms of coding, I could definitely clean up a lot of stuff here. I mean, if you were on the stream, then you see that a lot of this code is kind of trial and error. And to be honest, a lot of that is just from the trial and error is based off me knowing how the shape, if you will, of how these dynamic programming problems generally take place. So that's why you kind of see me like hacking along. And though I had also off by one here, if you remember, but that's how I kind of mess around with that. Otherwise, I don't know if there's an easy way. I mean, and I think along the way I do try to articulate the problem a little bit in terms of yeah, like what I want. I think one thing that maybe is I don't know if it's super helpful, but the helpful, just kind of see how I debug is kind of the good thing about these subproblems, though that took me a long time to dig into, is that each subproblem has, like, you could calculate the smaller, simpler subproblems and like manually or something like that, and you could check those to kind of check your assumptions and something like that, and so forth. Um, like for me, even though I have all this thing, like I could, check to see if I get the correct answer for the first 4 elements, for example, or 3 elements, and kind of check those manually. Because very often, if you feel like your recurrence is right, then you just probably have an off by one. Or in my case, the base case, well, I had an off by one at some point, but also my base case was a little off because I just never calculated the cost of merging the final k elements here, and I kind of put this here, even though I shouldn't have, but that is a more common place to put it, to be frank, but it wasn't the case in this one. Um, yeah, I think I do want to explain this problem a little bit better, though. I don't want to hand wave it, though I don't think this is a good interview problem, so you ask me that. But yeah, definitely now too, if you want to ask me the way to kind of describe this better, I can. But basically, And some of this, presumes that you have an understanding of dynamic programming in general. Because if you, I mean, if you don't, then it's going to take me all day to kind of explain everything from first principles. Um, but um, but kind of this is my recurrence. So I did kind of evolve a little bit from generally whenever I see these problems where I'm like, okay, it's just things are getting smaller, and I kind of mentioned the parentheses problems, but these also apply to kind of what they call partition-y problems. Um, and for that, I start off with a left right in general, and I did this here because that means that what is the cost or price or whatever, what is the thing that you're minimizing? I guess it's literally just called cost, but between the left and right? And then me try to figure out how to go into it recursively and think of it as subproblems. In this case, X being the number of powers left was good enough for me. And I kind of wrote this here, where it's the cost to do from left to right with X powers left. Uh, I already kind of explained this, and with X powers, it just means this stuff with 1 power left, and then this with X minus 1, because let's say you have 5 powers, you want to brute force the number of ways to that. So what this is saying is just the first parentheses, right? Let me ASCII art a little bit more. So that is the location of your first parentheses. So like you have, and then it kind of you iterate through that. So it goes from here to here to here to here, and so forth. And these are uncertain, and then these will subdivide into X, like say 4 powers left, right? So then your subproblems will be, this but 4, and then you find division that way again all the way through. Um, I know it's still a little hand wavy, but yeah, but when I get to 1, then that's when I have all the pieces together. Um, yeah, and there are a couple of ways you could get to powers equals to 1, as I kind of shown before. Let's say k is equal to 3 in this case. Also, if you have 3 elements, uh, then it will do the do this thing here. So if you and you only want 1 pile from 3 elements, so then it just this is equal to some real number, right? So then now you have some real number here, and then plus all this stuff over there, kind of. I hope that's and if you have more than 1 pile, so for example, this is 1 pile. You have X is equal to 4, or this 4 buckets. Then you actually, well, you want it in 3 piles instead. Yeah. Eh. Yeah, so I think that's kind of the general logic, and then a lot of my base cases kind of go through what does that mean if that's the case. I actually didn't even delete this. I forgot to delete this, which I guess is fine. I mean, it just never happens. Which is, well, if there are more piles left, that like if you want 10 piles, but there are only 5 buckets throughout, then that's impossible. So I return infinity. If there's only 1 bucket left, and you only need 1 pile, then that's great. Then you don't need to do anything. There's no cost, because that's just what you're returning. Otherwise, it's infinity, because you need more piles than which I think actually is taking the case here. So this isn't even necessary per se. The other case is if you have 1 pile left. Well, if you have k buckets, then that's the cost, right? You merge them all together, and that's what I put here, which is the sum of the elements. Otherwise, you just do you do it recursively. So instead of 1 pile, now you want to have k powers, which is in case there's 3 powers, and then you just kind of like, do the math that way, and then see, or like that's the recursion, right? And then this one is also, yeah, if you need x piles and you have n buckets, then you don't that you're done, right? So that's what this means. And then otherwise, we do all the recurrence that we talked about before. I still don't. I mean, this is very hard for me to explain, because I don't know. It requires a bit of dynamic programming, which I guess I have good practice on. I mean, I think this is a great problem for me to practice, but if you're interviewing, I probably would do a lot of the easier dynamic programming problems first before getting to this one. I mean, I think that's fair. So yeah, okay. I mean, I think that I'm gonna call it the end of this problem.